Okay, so an object of mass 30 kilograms is placed on a smooth plane, which is inclined at an angle of 20 degrees to the horizontal. It says then, label all the forces acting on the object and resolve the weight force to find its components parallel and perpendicular to the plane. So we're going to apply what we've learnt in the previous subsections, previous videos here, to when an object's on an inclined plane. So it says here to label the forces. So the main force is the weight. Okay. So remember, the weight comes from the centre of the object. Okay, but it goes vertically downwards. Okay, and it's important to remember that, right? That it does go downwards. It doesn't matter if you're on an incline. The weight is still directed downwards towards the centre of the earth. That's why we find it hard when we walk up a hill, okay? Because our weight is still going centred downwards, and it's making it difficult for us then to walk up. As we see now, there's actually a component of the weight then, so pulling us down that hill. Okay, so we've got a weight, but of course we've also got the reaction as well. Now the normal reaction, okay, will always be perpendicular to the plane. Okay, so that there is going to be right angles here. Okay, 90 degrees. Reaction is always 90 degrees to the plane, always perpendicular to the plane, okay? And essentially the road, or whatever this is reacting to the object, isn't it? It's holding it up, because if it wasn't, the object would just go straight through, so the road is reacting to it. Now what I want you to do, when you draw a reaction in, right, you should really keep the ruler there, okay? And that line for the reaction, keep drawing a line down, a broken line, okay? Because what you'll find then is, okay, we can then use this line to work out the weight component. Okay, so the weight, of course, if we fill this in, well, it's 30 kilograms, okay, mass, so that means the weight will be mass times gravity, okay, and we can then find what the component is perpendicular to the plane and parallel to the plane. So what I'm going to do now is draw a dotted line here parallel to the plane, like that, okay. Now before we do it, we need to understand a couple of things about angles here, okay. If you notice here, right, that is like almost forming a triangle, isn't it? Okay, you can think, you know, if that line carried on down, this would be a right angle triangle, yeah? So then with this right angle triangle, maybe I'll draw it over here so it's a bit clearer still. Okay, you've got this weight, as I said, coming down here, which is representing by that force there. That's a 90 degrees here, yeah, because it'll hit the ground 90 degrees. That's 20 degrees. If we think about it, if that's 20 degrees, that's got to be 70 degrees, doesn't it? Okay, because these two would have to add up to 90, with that being 90 there. So that's 20. You just take away from 90 to get that. So that's 70 there, yeah? That angle there would be 70. So if that's 70, let's think about what this angle would be. Well, this angle then would have to be 20, if you think about it, yeah? Because if that's 70, that's got to be 20, because we've got a right angle here, yeah? That dotted line is perpendicular to the road, so 70 here would make that 20. And that's always going to be the case, okay? Let's see if I can squeeze in 20 there. That's always going to be the case. This angle here to that dotted line will be the same as that angle there, okay? So let's work out what these components are, all right? The weight, let's work out what they are. Well, it might actually help if you turn it around, because if we turn it around, sheet around, you can now see the force here, that weight, okay, and then the two directions, okay. So I know that's not horizontal and that's not vertical, but turning it around like that sort of helps you see what's actually going on, okay. So maybe I could draw that down here, okay, so we can see it a little bit better. I'll turn it around again now and you'll see what I'm talking about. So what you see here, okay, with the 30 kilogram, the weight there, acting downwards, 20 degrees to this line here. Well, if I sort of look at it like that, okay, I can work out then that component and this component. And as we saw before, where the angle is here, this is the adjacent, isn't it? This is the adjacent side where the angle. So with the angle adjacent, we're going to have cos. So that's going to be 30g cos 20. And then opposite the angle, okay, opposite the angle, which is here. This side here is opposite the angle, and this side is parallel to there. So you get 30g sine then with opposite. So you get that. Okay, so now if we connect it to our diagram up here, you can see that's going to be 30g cos 20, and this is going to be 30g sine 20. Okay, so that's the component resolved then parallel to the plane and perpendicular to the plane.